I know I'm gonna have to do it anyway. Yay. How you doing, man? It's good to see you.
Sorry, little discussion of our
Oh.
It's 10 o'clock already.
Yeah.
You made it.
I did, and I think I finally figured out all this. Good to see you, by the way.
Yeah, you too.
It's
yeah.
I think I finally figured it out.
Yes, I know Greg had a lot of issues yesterday. So I know we're not supposed to sign into this.
That's what
We
I.
tried to do that
Yeah.
yesterday.
Yeah, exactly right.
Yeah.
So I'm, and I hope I have enough battery because I forgot my power cord, but I'm sharing slides from here.
Yeah.
And that's, I think it should work, but I won't be able to see like who's in queue and all that. I'm trying to sign in on this computer so I can't see it.
Yeah. I'll sign it.
Yeah, that would be great.
Yeah, I'm sorry I sent you this email. I overlooked that other email you sent you. I mean, you sent one email saying I'll send the slides shortly.
Oh.
Someone overlooked that other email. No, I found it. I saw you had already uploaded this.
Oh yeah, I just did it just a few minutes ago. Yeah, so I think we should be good.
Yeah, we should be good. Yeah, pretty short agenda.
Yeah, but I think Nate's discussion could be lengthy.
Yeah, I mean, it's great to have so much time. We can have some pretty long discussions. Sorry.
So we may want to do his was already towards the end, but it may be best to have it at the very end. Because Brian Haberman wanted to be a part of it, and he's got a conflict. So anyway.
Yeah, we'll see. But
and,
yeah, we got lots of time.
Yeah, we should. You're right.
Okay.
Oh, here we go. I finally got it. I think I got it.
Yeah. Okay.
Should we go?
Yeah.
I can't get onto the internet on this computer.
So we have to run the slides on this one, right? That's because that's what is displayed on.
It's from here.
Yeah. Okay.
This is just a separate. I'm trying to get this one work, but the slides are coming from here.
Okay.
And that one's nothing. And you just maybe can sign into MediaCo on your computer so we can see who's in the queue and stuff.
Yeah, we can see it here.
Oh, can you see it there?
Yeah,
oh, okay.
Yeah,
okay. Perfect. Okay. Should we go?
Otherwise,
should we go then?
Remind people to scan that thing for the blue sheets.
There you go. Hit it.
And also to wear masks. Yeah, I'll do that.
Yeah.
Okay, sure. Yeah. But welcome everyone to PIM at IETF114. This is the second physical meeting. It's my first or our first in a while, so it's exciting to have a physical meeting here. Yeah, I think maybe most of the participants are remote though, and thanks for joining us. A couple of things to remind people. You should scan the QR code over there, or there's also one by the entrance. That's for the blue sheets. Or if you don't want to scan that, just go to Meet Echo and basically register, sign in so that you're in the queue, because then you will be part of the blue sheets. We've also been asked to remind everyone to wear masks, but it looks like everyone is doing great here, so thanks for that. Um, yeah, I think there was some possible exception for chairs, but as long as you can hear us okay, I guess we're happy to wear our masks. So yeah, let's start with a status update. Sorry, yeah, you're taking notes, but
Actually, I can't take this. Yeah,
okay.
I'll take notes.
Okay. All right, so here's the note well, so you should know this by now. It's more or less how the IETF works, and yeah, it's something everyone should know. Next slide. This is the agenda. Any concerns about the agenda? Look okay? It's a very short agenda this time, but right, yeah. Okay, so we may rearrange a little bit. Like Brian is not here yet, so he will be a little late, so we might push that to later. But yeah, we'll see how that goes. Okay. Yeah, I should have that here. All right, so this is the working group status. So we have a PIM-YANG model that is still in RFC editor's queue. I think last IETF I was kind of optimistic, thinking it would be published soon, but I think it's still waiting for references for other documents. There's a whole bunch of YANG models that probably will be published at the same time, just because of all the references.
Hey, Stig,
Yeah, hi.
I just checked on that because the OSPF Yang models in that situation too.
Yeah.
And the redo of the BFD model is going to go into OFF48. And Mahesh J says he's going to push that through as quickly as possible.
Okay.
Yeah, and then once that's published, then that is the reference we're all waiting for, is the RFC, forgive me if I get the number wrong, 9127 BIS, which is fixing the BFD configuration parameters. So you can either specify the parameters within the protocol when you do it, or you can specify them externally, because different vendors did it different ways. Okay, hopefully I didn't take too much time.
Okay, yeah. Okay, great, thanks. Yeah, so at least, yeah, it's taking a while, but it's in the queue. It will be published, yeah, in not too long time, it sounds like. Yeah. Okay, great. Thanks. We also got the IGMP MLD extension draft that is in the RFC editor's queue. It actually is in like auth48 now, so it should be published in a few days, I think. Then we got the DR drafts, DR improvement and backup DR. We need to do some work on those. Okay, Mankamna, you got a comment?
Yeah, Mankamna Misra from Cisco. So yes, both of these drafts we will be working before next IETF, because the second draft, which is IETF PIM BDR, so some of the sticky DR behavior that has been already implemented and deployed. So we will have update by next IETF.
Okay, thanks. But yeah, just some background. So basically, both these drafts talk about DR behavior, and one common thing is like backup DR. And as a working group, we need to find out, do we need both these solutions, or do we want to pick a solution? I think that's like the main concern we have. So, yeah.
And as Sandy has mentioned many times, one draft is focused on explicit signaling and one is not. So, so far, we as a working group have adopted both. We think there's reasonable reason to have both solutions, but as far as you and I are concerned, I guess we just let the authors drive their drafts, because we can't.
Yes, we need the authors to push this a bit more, and we also want all of you to please read the drafts and share your thoughts, and yeah, we need your help to figure out what is the best thing to do here, whether we want two solutions or not, which one is best, or yeah. It's a very simple concept in a way. I'm sure everyone here knows what a DR is, and it's kind of important to solve this. And we don't have a document, which is almost, I mean, it's almost strange that we don't have a good solution for this after so many years
Yeah,
with PIM. So, yeah, it's something we should solve, and it's a kind of fun or interesting problem. All right, okay. We also got the IGMP MLD proxy Yang model. But this in, yeah, we requested publication. And you actually got a couple more too. We got like the null register packing and assert packing that we also requested publication for. So we have several drafts coming up, or yeah, hopefully published sometime. I don't know. We'll see. At least they're in the queue. Sorry, next.
Yes.
Okay, then we have the SR point-to-point point-to-multipoint policy that we're not discussing this time. We'll have some update later on the IGMP v3, MLD v2 BIS, basically revising those RFCs.
Sorry, Human Bitcoin Nokia. I think there was an email to the working group asking for last call on the point-to-multipoint policy.
Oh, okay. Okay.
That's why we didn't bring it up.
Oh, okay. Okay.
Thank you.
Okay, sorry about that. Yeah, so we should see how many people have read it.
Yeah, let's do it now.
Let's do it now. Yeah. Okay, so for the point-to-multipoint policy, how many people have read the draft? Yeah, I guess it's okay. We got remote attendees as well. I guess the main question is really: do you think it's ready for working group last call, or do you think there are any issues? I think we need to do a poll on Meet Echo. Check.
Yeah, but I can't because I'm sure
Okay.
slides.
Okay. Yeah, and of course I'm not prepared.
We
Can poll the room first, maybe. Oh no, it's not fair to do that first.
may have to send it to the list.
Yeah. Okay, let's do that. Maybe after the first presentation, then I'll be signed in and ready to do the poll. Yeah. Okay, so I'll do a little poll and ask you guys about this in 10-15 minutes or something. All right. Then we have the Lisp extensions. Nothing has happened with that for the last IETF and nothing this IETF. So the authors need to do better. I'm saying that because I'm one of the authors. We'll do an update on that soon. Got the point-to-multipoint policy ping. Homan, do you have any comment on that, or?
Yeah, last time we went to the MPLS group asking for some comments. I haven't got back any feedback yet, so I need to follow up on that. But I think the only thing that is left there is getting a sub-TLV assignment from INAA.
Okay.
And if there's no other comment from MPLS group, then maybe we can do a last call on it.
Yeah.
So I'll put something together for the next IETF meeting.
Yeah. Okay. Great. Thanks. Yeah. And the last draft we have is the MRF like to call it TILFA, but anyway, that just got adopted. So that's great. We did the adoption call just a few weeks back, and there was good support. So, but yeah, it's not been. No, actually, we do have a presentation for that. Yeah, shortly. Yeah. Okay. Yeah. So that's the status. So I guess we can move to the first agenda item.
Do you see? Oh yeah, Eson's on the line. That's good.
Okay.
Okay, so let's.
By the way, HC, I see you are in the queue here, but you probably just
Hello?
stay there from before, right? Yeah. Okay, yeah.
Uh,
All right. Okay, yeah. Song, we are ready for your presentation here.
yeah, yeah.
Yeah, here we go. Okay.
I think. Thank you. Uh, okay. Hello, everyone. I'm Yisung Liu from China Mobile, and today I will present the MOFR based on the TRFA. It was just adopted last week, and I'll give some brief introduction and updated information. Next slide, please. Okay, this is the brief introduction, and as we all know, for the RFC 7431, we have the PIM-MOFR mechanism to protect the PIM, and for this draft, we provide a new mechanism by using the TRFA for the PIM-MOFR with no additional extension of PIM protocol. And we will just update the detail of the restrictions of the PIM-FR based on the RFA and the remote RFA. And the next slide, please. And for the RFA to the MOFR, the PIM can establish the backup tree according to the normal protocol procedure of the RFC 7761, and it can send the join hop by hop to establish the tree. And next slide, please. For the MFR based on the remote RFA, and the PIM join can carry the RPF vector of the type 0 join attribute to take the PQ node. And the PQ node, like the picture in the R3, we can establish the first part of the backup tree till the R3, and the second part of the backup tree from the R3 to the original multicast source. Next slide, please. For the restrictions of the MFR based on the RFA and the remote RFA, because the RFA and the remote RFA algorithm are all topology dependent. So the MFR based on the RFA or remote RFA cannot cover all of the network environments. For the example in the picture, if the R6 then the PIM join to establish the backup tree, it will send the packet directly to the R5, and R5 will forward it back to the R6, and it cannot to establish the tree. And if we use the remote RFA based MFR, and the P space and the Q space do not overlap. So if we use the R4 as the vector of the type 0 join attribute, one the packet forward to the R4, R4 will forward it to back to the R5. So it cannot establish the backup tree either. Next slide, please. So for the Unicast, we can use the TRFA to get theoretically 100% covered and network protection. The alternate paths provided by the TRFA for the segment repair list. Including the node seed and the agency seeds. So next slide, please. So for the PMFR, we can also use the TRFA parse to build the backup tree, and we can use the node seed as the RPF vector of type 0 join attribute, like in the picture R4. And we can also use the adjacency seed as the explicit RPF vector of the type 4 join attribute. And it can, firstly, it can establish a tree from the R6 to the R4. And secondly, it will directly send the join to the upstream neighbor and R3. And then it will join hop by hop for according to the normal procedure of the PIM protocol. So the backup tree can be established. So next slide, please. For the next step, we will add more details for both in the SRMPLS and the SRv6 networks. We can run PIM MFR in both network, and we hope to get more feedback from the working group. Okay, that's all. Thank you.
Yeah, all right, thank you. Any questions in the room or online as well? All right, yeah, thanks for that. I guess we don't have any questions, but yeah, it'd be great if everyone reads the draft and give any comments online. All right, okay, thanks.
Thank you. Okay.
Let's do the poll next. Let's have it ready here. The poll for the.
Go ahead and do it.
Yeah,
You got it?
yeah, I have it ready here.
Okay, yeah. I'm gonna try to figure this out.
Yeah. All right. So for the SR point-to-point, point-to-multipoint policy, let's see if it's ready for last call. I'm going to start a poll on Meet Echo. So I'm not quite sure whether when we do these polls these days, if everyone's supposed to use Meet Echo or if we do a combination of the room and Meet Echo. But I think if you're in the room, it's it should be sufficient if you show your hands. But yeah, so let's say if you're in the room, you can okay, Alvaro, what should we do?
Hi, Alvaro Andy. Just something really quick. Everyone should scan the QR code at the entrance because that's equivalent to blue cheats. So if you do that, you're logged into Meet Echo on your phone, and then you can just do the poll on the phone too.
Okay, let's do the poll for everyone. Yeah, are you all logged in and ready for the poll? Otherwise, we can wait a little bit. But okay, let's do the poll.
Is there an app?
Yeah, if you scan that, it's like Meet Echo Lite or something for your phone. Yeah. Okay, let's do the poll. So yeah, so you should all be signed into Meet Echo, hopefully, and see that the poll. So basically, gonna start this poll to check if the point-to-multipoint policy draft is ready for working group last call. So the question is really whether you think it's in a good shape and no major issues, or whether you feel like it needs more changes first. Okay, so I'm starting the poll here now.
Oh,
I think we
13,
can
42
more or less-
against?
yeah.
Oh. Is there anything against?
Yeah, I wanna ask people why
Can you
they're.
scroll up? Does it show anything? Is there another option?
Oh. Okay.
Oh, okay, that's it is. Okay. Oh, 3 against then.
Hmm. Okay, it's still changing. So
Oh, okay.
okay, there's still some more votes coming in, so we'll wait a little longer.
It's a feature request for
Mm.
Okay, yeah,
That 39 on there?
39 are the number of people that are attending, but 16 are the number of people are participating in the poll.
right.
So it'd be nice to know out of the total people that are participating, who doesn't, total number of people who are in the working group
Right.
are the same count as participants in the poll.
Oh, yeah, no. So the participants in the poll are the actual people who actually either raised their hands or explicitly didn't raise their hands.
Exactly.
So in other words, yeah, the other 15 probably didn't read the draft, right?
Yeah,
It'd
but it would be,
nice to put that-
yeah,
It'd be nice to put.
Oh,
that
you mean
there so
abstain?
we know- Yeah, that's a feature request.
I agree. That's a big rate. Yeah, just to know how many are not responding at all, or yeah.
Yeah.
Okay, so yeah, I think it hasn't changed for a while now, so we'll stop here. So yeah, we got 14 people in favor or saying it's ready for last call, but we also had 2 people saying it's not ready. So I would like, yeah, if those of you that think it's not ready, if you have any comments, I mean, I would be happy, or we would be happy to hear if you have any, thoughts on what is missing in the document. If you would like to respond, it's okay if you don't, but yeah, it'd be great to know what is missing.
So Human, can you remind me again? I'm taking notes, so I'm just catching up here. So this draft we're waiting on the status of the replication segment draft in spring. And
Yes.
what's the status of that draft in spring right now, did you say?
So I think it's in good state too. We are trying to do a last call on that one too, on the replication segment. So
Should we wait to do our last call before that one, or do you think?
I don't think so. I think it's more appropriate to do a last call on this one first and then go to the replication segment. The reason for that, just to refresh everybody's mind, is that this draft in the PIM, it actually talks about the tree and the point to multi-point policy that you set up on the root. And the replication segment draft in spring talks about really the forwarding plane, how the multicast instructions are built, right? So this draft is really talks about how the tree is built up via candidate paths and how they can be assigned to a MVPN type of infrastructure. In my humble opinion, it makes sense because this is the mother draft to do a last call on this first, and a spring is a separate beast of its own.
Yeah.
But that's just my opinion.
Okay. So probably what we should do, like we've been doing, is just maybe touch base with the spring chairs and just let them know what we're doing and make sure that they're cool with it. And
Right.
then we'll proceed.
Yeah, so we did the poll here, but we'll check on the mailing list too if people think it's ready, and yeah, it looks like maybe some people have some concerns, but yeah, if anyone has any concerns or comments, we want to hear from you on the mailing list.
Yeah, I mean, absolutely. That's what the last call is for, right?
Yeah.
Any comments, any thoughts that comes in mind, please let us know, and we'll definitely discuss it. Thank you.
And yeah, we want you all to read it, and any comments would be very welcome. We often have an issue with getting enough review of documents, so yeah, that would be great if you can have a look. And yeah, we'll check with the spring chairs, and we'll probably send an email or two and say, there's a last call in PIM, and please have a look. All right, okay. Then I guess PIM Lite is the next one.
This one facing the wall. All right, thank you. It's good to be here, seeing everybody. I'm smiling behind the mask, but the mask is covering, but that's fine. Yeah, so PIM Lite, just to give everybody overview of what's going on here, is eventually in this meeting, we want to see whether we can adopt this draft as an IETF draft and move forward or not. So this presentation, eventually the end goal is that. Next slide, please. So, I mean, we've done the background a couple of times, but just to refresh everybody's memory, there could be two PIM domains that are disjoint, and you might want to signal multicast states between these two PIM domains. And to do so, you don't want to bring the PIM adjacency up or the PIM neighborship up. Sorry, it's hard to breathe and talk with this thing. You don't want to bring the PIM neighborship up between the two PIM disjoint routers. So basically, you just want to use the join and the prunes messages between these two PIM routers to communicate the multicast state. One of the best examples for it is PIM signaling over the beer network. So obviously in RFC 7761, it was described that for PIM joins and prunes, well, the assert message should not be there, because in the next slide you will see that was a mistake by me. For PIM join and prunes, you need to make sure that there is a PIM hello message and adjacency up before you process those joins and prunes. And a PIM Lite interface is basically an interface that allows you to process those join and prunes without bringing up a PIM neighborship between the two routers. Next slide, please. So on the version 2 of the draft, a couple of decisions were made. So we are keeping the name as PIM Lite. There was some back and forth, whether it's light, whatever it is. I think we are keeping the name as is. Again, the goal of the draft I already explained. So for the sake of time, I'm going to skip that. In the new version of the draft, based on discussion with some of the experts, we removed the assert messages. Basically, we feel that when the two PIM domains are connected via a PIM Lite interface, there is no need for assert messages, and the PIM boundary routers, they need to ensure that they are not duplicating the multicast traffic from one domain to the other domain over the PIM Lite. And last but not least is when it comes to the PIM Lite interface, there could be two cases for configuration. In one case, you might want to explicitly configure the PLI on the router. And if you do so, then basically you don't want to accept any joins or prune messages on these on non-PLI interfaces. In the second case, like beer, you could have PLI configured automatically on the beer-facing interfaces. And again, in that case, for security reason, we don't want to start processing all these join and prune messages on all the interfaces throughout the router. So it is suggested that for these automatically cases that PLI is going to be configured underneath the hood, there should be a mechanism to understand that these PLIs are facing the the beer domain, and explicitly on those interfaces, we accept the join and the prunes coming, I guess it would be from downstream, coming from downstream. Again, these are security concerns. And I guess this last point is something that we can discuss a little bit further to understand whether this whole configuration and security mechanism is necessary in this draft, or we should omit it from the draft. But anyway, that's one point of discussion. Next slide, please. Yeah, so those were the changes, and I guess what the authors they feel like is it's ready for adoption, and take it to the next slide.
Is Sandy online? She's got to chair this thing.
Yeah.
Let's see. Sandy, are you online? Sandy is. Oh yeah.
Okay. As a shepherd, I do support the adoption of this draft, and I think that it's great if more details can be added in the draft, such as some comments from the last meeting. And I also think that if we received a hello from the PLI, what will we do? If we should think that it's a valid packet or we will do something. I think the details such as, for example, for the hello packet process need to be added in the draft too. But I do support the adoption. Yeah.
Yeah. So thank you. So the reason that I called your name out is because you're acting as chair for this draft. So we need to have you be the one to ask the working group if we support adoption of this draft, since Stig and I are on the draft. But before you do, there's a comment. Yeah.
Hey, Rishabh Parekh, Cisco. So I don't know if authors need to consider that today Boots BSR message forwarding also needs PIM neighbor on an interface. So I don't know if that has to be considered for this draft. So
Sorry, VSR messaging?
yes, the bootstrap forwarding requires PIM neighbors on an interface. On a string router has to forward BSMs only on interfaces that PIM neighbors. So if you don't have PIM neighbors, then we need to consider how BSM will be forwarded.
Yeah, speaking as an offer, I guess. Yeah, I agree. We need to mention that, and can probably just be a statement saying, that they are not supported, and you need to configure RPs in some other way, probably. But yeah, it needs to be mentioned, I think. Should probably look at all the PIM message types and make sure that they are all covered in some way, like mentioned,
Okay.
I know you're kind of saying you only support joint prune.
Yeah.
It might be good to sort of mention, why those other messages are not needed, or
Okay.
how to avoid them.
Understood. Yeah, I can put a paragraph for it. Thank you.
Sandy. So yeah, we need your help here. Do you think it's ready for adoption, or do you want to ask the working group if it's ready, or if it's not ready, that's okay too. But yeah.
I'm going to guess that we need to have her asked on the list.
Yeah.
I'm not sure she understands it.
I mean, should we do a poll, or?
Yeah, I
Yeah.
guess we can do it.
Yeah. Okay. Let's start a poll.
Thank you. Lynn.
Yeah. Yeah. Thank you.
Hello. Do you hear me?
Yep.
If you asked me that if this draft should be adopted, I just said it should be adopted.
Yeah, we just need to have you ask the working group. You're chairing this
Oh.
draft, so that's what we're asking. But we're going to go ahead and initiate a poll. But on the list, we're
Okay.
going to need to have you send an email out to the list asking for opinions on adoption. But we'll talk to you after this meeting.
Okay. Thank you.
I don't know if this is fair on me, but let's say, yeah, as an offer, not working group chair, I would say that, this is motivated by beer, but there's other implementation doing this kind of behavior in various contexts as well. But we never had any document describing how to do this, or it's more like implementation specific thing so far. But yeah, let's start the poll, and Sandy will check on the mailing list. So the poll here is just to get some idea. The mailing list is what counts.
Yeah. So you're starting the poll now?
But yeah, I'm starting the poll here now, whether it's ready for adoption.
Okay.
Yeah, I think that's probably long enough. So right now we got 13 people in favor of adoption and 1 person against. So at least we have pretty good support at least. So we should definitely take it to the mailing list. But the mailing list is what counts. So please respond to the adoption call on the mailing list. Okay. Yeah. Thanks.
All right, Nate, are you ready to hit it? Let's just go. We'll go in order. So, thanks.
Yeah, Brian is still not here.
Yeah, he's not here. He's online.
Okay.
All right. Good morning, everybody. My name is Nate Karstens. I work for Garmin, but I'm here representing the National Marine Electronics Association, specifically the Onenet Committee.
I think you can raise it by that bottom thing down there. Yeah.
Oh, there we go.
And then.
There, is this good?
Yeah, that's better. Yeah.
Perfect.
And you can tighten it too. Yeah.
All right, so a little bit about the Onenet Networks, because it might be a little different than the networks you're used to looking at. These are mostly self-contained. They don't have typically internet connections. If they do, there might be like a satellite. NMEA has 3 different standards. 0183 is something that you probably have in all of your cell phones because that's what a lot of the GPS chips use. NMEA 2000 is a CAN-based network. And then we're working right now on Onenet. We've published it and are currently, it's in early stages of adoption. So specifically right now we're working on some radar messages for that. But what you can see, the target market for this is anything from like smaller recreational boats with 1 display, a couple of sensors to larger tankers or container ships like this. So. And again, typically these are not connected to the internet. So what we're looking at is a lot of sensor traffic being transmitted to displays for the pilot to kind of digest and use for navigation and safety and life critical type stuff like that. Next slide. So there's a couple of different problems that we're trying to address here. The first problem is related to the coexistence of devices with varying link speeds on the network. So this is kind of illustrated by this. We've got on the right a 1 gigabit sensor, in this case a radar, sending traffic off to a 1 gigabit display. But then you might have a lower cost sensor that only has a 100 megabit or even maybe a 10 megabit connection to the switch. And so just in a standard switch where the traffic goes everywhere, multicast traffic goes everywhere, that's going to go out on that 100 megabit link. And even if the sensor itself filters out that traffic, is oftentimes the network interface chip has the ability to censor that so it doesn't go to the CPU. But even if it does filter that out, it will still overload that link. And so important traffic will get dropped by the switch. Next slide. So to solve that, we use a technique called multicast snooping. Each data stream is assigned a different multicast address, and devices only request streams that they are interested in or can handle. So what multicast snooping helps us with is you have a managed switch there, and the switch will receive IDMP or MLD join messages and send those up to the CPU. The CPU will use that to kind of program the switch part to only forward the multicast traffic to a given port that has a device that's interested in it. This kind of expands here if you have several switches all chained together. Those multicast join messages will kind of percolate through the network, and each switch will be configured according to if there's any device attached to that port that's interested in that traffic. So in this case, the 100 megabit sensor does not request the traffic from the radar, and so the switch does not forward the traffic there, and the link is available for other important traffic to get through. Next slide. So just kind of a rehash on some of the IPv6 addresses out there. The standard that we're working with is almost entirely IPv6, but some of these concepts would apply to IPv4 as well. So Unicast address has a, and this is a link local address, so the first part of that is going to be FE80, and then the last 64 bits are the interface ID. Next slide. When we start looking at multicast addresses, according to RFC 4291, the lower 112 bits of the multicast address is the group ID. Then when you look at 3306, there's a kind of the next iteration of this, which is a Unicast prefix-based IPv6 multicast address, where it calls out that it kind of divides up that 112 bits into some reserved, the prefix length, the network prefix itself, 64 bits, and then the group ID is shortened to 32 bits. Then you get into a link-scoped IPv6 multicast address, and this is a really interesting idea. It basically allows each device on the network to have a group of multicast addresses that are automatically assigned to it as kind of a benefit of getting a link local IPv6 multicast address. And what happens here is that network prefix is the interface ID taken from the link local address. And then the group ID is allocated as per 3307. Next slide. So some guidelines from 3307 on how the group ID is allocated. There's different ranges. Basically, there's a permanent IPv6 multicast addresses, and those are allocated by IANA. There's a link to the registry there. And then there's a permanent group IDs, again, allocated by IANA. And then there's dynamic multicast addresses. So basically, if the most significant bit is set, then it's a dynamic one. Next slide. So the problem with this is when you go to transmit this on Ethernet, there's the potential for collisions. RFC 2464 specifies that the destination multicast MAC address is the first 2 octets or 33, and then the last 4 octets are the last 4 octets of the IPv6 multicast address. So if you look at a link scope IPv6 multicast address, those last 4 octets are the group ID, and the group ID is not differentiated between different interface IDs there. So different nodes can generate different link local addresses with the same MAC address. Next slide. So we looked at a number of solutions to this, and one that I left out of the slide, and I'll start with, is having the switch itself look at the IPv6 address. But RFC, I think it's 4541, talks about, kind of gives an overview of multicast snooping, and there's a survey that they did of the various vendors, and most vendors are not looking at the IPv6 address when they're making switching decisions. They're just looking at the MAC address. So other solutions are source-specific multicast, and that's not universally supported by switch hardware. Seems to be more for multicast going between different networks. There's MADCAP, which is discussed in RFC 2730. And this uses a central server to allocate addresses, which and allocate dynamic addresses, which would be a great solution in many types of networks. But for the networks that we deal with, we try to avoid single points of failure because the environment we can operate in can be pretty harsh sometimes. So we could basically take this and find a way to shoehorn it into the protocol. We could auto-negotiate a MADCAP server, provide some sort of failover mechanism, and provide a comment format for lease databases. And that would be probably fairly tailored to our solution and not really usable by anybody else, at least not easily, and it wouldn't be an easy way to do it anyway. There is another protocol that's in a draft called ZMAP, which is, I think, zero conf multicast address allocation protocol. Never published. The draft expired in 2003. And there's a lot of things that are missing from it. Specifically, the addresses and ports are listed as TBD. Next slide.
Yeah, I have
Excuse
a
me.
question.
Sure.
Yeah.
Lenny Giuliano, Juniper. How are the receivers expressing, trying to join? Are they just sending standard IGMP or MLD reports, or is there some other protocol?
Yes, they're using the standard IGMP or MLD reports.
Okay. And you say source-specific multicast is, it's not, SSM isn't universally supported by switch hardware. What specific, is it like MLD v2 is not supported on hardware? What parts of SSM isn't?
Well, it's mainly the tables that they use to make decisions as far as which addresses are forwarded to which ports. Don't have any sort of entry, database entry there for the source address. It's all focused on the destination address. So if you look at the vector and the address translation unit, there's basically one vector, which is a bit field that says these are the ports that this address is on. And then there's another buffer for what the multicast, the destination address is. And that's basically it. There's a couple of other things in there, but you would expect there to be some sort of entry there for
The source.
filter out by the source. But even then, we're looking at the source MAC address, not the source IP address. So if you're looking at something where it's coming in from another network, you would then find yourself having to put in the source address of the router. So it gets a little weird.
The snooping mechanism used by the switches, is that just plain old MLD snooping or something else?
The
snooping mechanism used by the switches to determine if a port has an interested receiver and block it otherwise. Is that just standard MLD snooping, or is it something else?
Yeah, it's basically standard. What we find is that the switch part itself provides a functionality where it recognizes an MLD or IGMP message, and it'll forward that up to a CPU. And then the CPU reads that and says, okay, well, based on this, I've got somebody interested in this data on this port. So now I've got to modify that entry in the address table to forward traffic onto that port. So there's this partnership between the switch part and the CPU itself. Now, maybe other switch parts kind of do all that for you, or maybe include a CPU on there.
So just it's basically doing MLD snooping, but it can't look at the source. It can only look at the group address. Is that the issue?
That's right. Yeah.
So it's so it's more like a more or less hardware issue, whether you are capable of filtering on the source or not, I guess.
Right.
So
Okay, yeah.
so wait a second. So if you are only
this is
doing
Taurus,
ASM,
by the way.
Taurus accurate. I was missing completely where the problem is, right? So are you doing ASM or SSM? If you're doing ASM, you basically are saying that, everybody that is interested in the group receives it from all the sources. If that's not what you want, you need to use SSM. But
Right.
I mean,
yeah. So we looked at
instead of just repeating all the things we've done through history.
If all the sources and receivers are connected to a layer 2 switch, it doesn't matter.
No, this is a question about what degree of hardware capabilities do you need in the layer 2 switch for the snooping part, right? That seems what it's boiling down to.
that could be.
He said it supports MLD snooping. So.
Right, but what are you trying to do? The use case that you explained said that only the folks interested in something join a group, so that's ASM. Is that what's sufficient, right? So if you're joining the group, you're only getting the traffic for that group. Is that sufficient for you?
That would be sufficient, yes.
Okay,
Yeah.
and what's not working about that?
What's not working is that we don't have a good way of allocating those multicast addresses, dynamically assigning them in a zero configuration environment.
And what's the most simple use case where I can see how dynamic assignment would be necessary?
The earlier diagrams where we have a high-speed sensor and a low-speed sensor connected to the same network.
Okay.
We want to have different speeds of traffic only be directed to the ports for sensors or devices that can handle that?
But give me another example where you're doing anything similar and you're not relying on pre-allocated static addressing. I mean, that's basically what most everybody uses, and somehow we've survived 3 decades with that, and we're all happy that this stuff in the 90s didn't get adopted because everybody figured out some easy scheme to use, static address allocation or other workarounds on these protocols, and people have wasted 300 pages of wonderful documents about this.
He's asking for help.
Right. So no, I'm just saying in terms of if we want to bring any of this stuff back for the dynamic allocation, I'm trying to explain the history that we had 30 years, people of giving up on the idea and coming up with simple, pragmatic, static address allocation management schemes. And we have published a lot of RFCs about that as well, right? So I'm trying to answer to him.
So that's a good question. I mean, I think that's probably a fair thing to require of somebody that's installing a network on a big tanker ship, but a lot of the users that we have are weekend fishermen. They don't understand anything about networks, and so we try to take care of as much of that as possible for them.
These are all standalone networks, so every stuff that's being deployed is going to be running in a separate instance of itself, which is why you can very easily, come up with deployment profiles that say, okay, the equipment by default, unless you configure it differently, will use the following, addresses.
I mean, are you suggesting that? Well,
everybody is hard coding multicast addresses into their applications, and everybody gets problems with doing that once you get into larger networks. You don't have larger networks. You have something very well predictable in terms of how much equipment that needs how many different speeds. So you come up with an address plan. We can consult on that perfectly well, and that gets hard coded into the devices. That's what everybody's been doing, and that guy has probably been answering hundreds of these requests for specific addresses on the IANA side, right?
Well, I disagree with that. Every network is the same. Boats are wildly different.
Right, but the question is, the classical approach would be to sit down and figure out if a static address allocation that foresees all the known possibilities, right, would be sufficient to solve the problem.
My opinion is that it would not be. I don't think it would be.
Right, but that's the point one needs to get to have justification, not to just do the, in my opinion, obvious, which, as I think, most everybody has done, right? If somebody really comes to the point of figure out, I need a dynamic allocation, then it's most likely these days going to be some more, application side with the controller stuff than trying to rely on network protocols.
I mean, I think the same argument could be made for assigning addresses to individual nodes, right? At some point, somebody said, why don't we just assign static addresses to everything? And somebody else said, well, it makes more sense to have a DHCP server.
Yeah.
Or link local addresses, right? So I'm saying that same thing applies here also to destination multicast addresses.
Yeah, okay, yeah. So Human next, and then we have 3 more people in line afterwards.
Just to give you an example, like we have the same type of issues with IPTV. We got 480 streams, 1080 streams, etc., etc. So maybe this is useful to you folks too. We use zero-touch provisioning to download the configuration to the router. As it was mentioned, we use a static multicast addressing via the zero touch. So when you download the configuration, the static multicast is within the configuration, saying that anything coming from this interface needs to go to a source that is 480. Anything coming from that interface needs to go to a source that is 1080. I don't know if it's going to be useful to you folks, but just to give you an example how we kind of mitigate this kind of issues.
Is it that you have like, do you work with another, like a server to kind of upload your configuration and then it configures it for you and you download that? I'm not sure.
Yeah, so zero touch provisioning, what it is Unicast comes up and you do a DHCP discovery to get your router IP address. And then based on a bunch of DHCP options, you go get your configuration, like in a DHCP option 61, You say that, hey, I am this router with my MAC address, and you get the configuration specifically for that router. And then the provider, since it knows this router is sitting in Los Angeles, as an example, it knows that interface 1, 2, 3, those are 480 streams. Interface 5, 6, 7, those are like 1080 or 4K streams. And it can assign the source addresses accordingly as a static multicast address to those interfaces.
Okay.
And it seems to be scaling nicely. I mean, it scales for IPTV, but just to give you an example.
Yeah. No, I mean, I think what we would try to avoid about that is having a DHCP server, because again, that represents a single point of failure. Now I mean, that's certainly an interesting idea in that you have some point in time where you configure everything, and everybody chooses that address and stays with that address, and that's certainly yeah, that makes sense. But even negotiating what those addresses are a protocol that we
we have
need to
a
do.
few people in line, but
Oh.
yeah, if you have a quick comment or.
Yeah, 30. How about RFC 3306? I'm not sure if you mentioned that. I think you said 3307, but isn't that exactly what would work here? It's just you can derive a multicast address from a unicast address in V6.
Right. So the problem with that is once you do have that unique IPv6 multicast address, when you go to transmit that on Ethernet, the group ID part is not unique on the network. The interface ID is unique on the network, and that's 64 bits. But the group ID, the lower 32 bits, multiple devices could basically choose the same group ID, thinking I'm guaranteed to have a unique multicast address, and it would be unique at the IP layer, but at the Ethernet layer, they would collide with each other. And that's what these switch parts are looking at, is the MAC address, not the IPv6 address, according to RC 4541.
Do you know the comments?
Your presentation was really good, by the way, and you were really well prepared and did a lot of research on all the possible mechanisms. So thanks for that. But I want to wait till you finish. Are you done with your presentation, or you still have more to?
Oh yeah, there's still more actually.
Yeah. So
Should I?
Whenever, I mean, I have some proposals, but if you have some other questions to kind of.
Well, I have a really simple solution, but I wanted to ask you some questions about your deployment first.
Okay.
But
Sure.
should we wait till the end of your presentation? Chairs?
Probably.
Okay.
Yeah.
Okay.
Just
Yeah,
wanted to
okay.
talk
We have
first.
two more people in line, but okay.
Just wanted to say I didn't want to sound dismissive, right? So I'm happy to help as well with this. It's just that, when people think about the solution, they come up with these things. Oh, no, I don't know the address. I need to learn the address. And the question is, okay, how do you learn the address? Well, I have a name. Okay, how do you learn the name? When you know the name, you can equally, have an address, right? So that's why a lot of these pragmatic solutions come up once you go through the different steps of the design process, right? And that's what I was trying to shortcut, but yeah, it's a little bit longer explanation typically.
Okay.
Okay, so yeah, I'm in line also. But okay, as a participant, so it sounds to me like discovery is like important to you, right? You need some kind of discovery mechanism. So SSM would probably not work, right? Because how would you know the source address, or can you see some ways of?
Yes, so the protocol that we're working with uses MDNS as a discovery mechanism for a lot of the services, and then oftentimes that will lead into some sort of REST API that publishes these, or it might publish it as part of a text record. But for the purposes of this, we kind of consider that kind of out of scope of dynamic assignment, although certainly wouldn't be against including that in whatever solution we eventually arrive at.
Right. So yeah, you could potentially use maybe SSM for the actual data traffic, but you need some way of discovering what to use, I guess.
Well, even then, I don't think the problem is that we couldn't discover the different sources. I think the problem is that the hardware doesn't support filtering based off of the source address.
Right. So yeah, I know you said, that you want some devices could handle the higher bandwidth, so it's important that
Right.
it's filtered. Yeah. Okay. Okay. Thanks. Okay. Got one more in line.
And just to be clear, when I say the hardware, I'm meaning the switch hardware itself. The actual nodes, of course, the link couldn't handle the speed. We're kind of assuming that the device itself may have some sort of mechanism in there to filter based off of the destination address.
Okay. Yeah. Yeah.
Go ahead, Zhuzhong.
Hi, can you hear me?
Yep.
Oh, thank you. Thank you, Nate. I think this is an interesting topic. My question is not about the whether we need a solution about dynamic multicast address allocation. I'm more interested in the scenario itself. Do you know the exact how many sensors and displayers will be there in this multicast domain? I think the picture showed in page 2 or 3, if I remember it right.
Sure. Yeah. Good question. So we're looking to support things that can be very, very small, just one display and one sensor, to potentially hundreds of sensors. You could imagine a container ship might want to have different sensors throughout the boat, temperature sensors, depth sensors, all that type of stuff. So basically a lot of flexibility in where the
so the number of
I mean, the number could be anything
okay,
from
understood.
2 or
So
3
the
to
number of the okay, so actually, I'm more interested in how many numbers about these players. Will there be a lot of displays or just several? Because we I asked the question about the scenario because we have met similar use cases in enterprise. So I think the scale is also matters. How to solve the problem.
Yeah, so Nate's going to share some solutions that he thinks as some potential scenarios. So yeah, why don't we let Nate do that now?
Okay, next slide. So read through.
Okay, thank you.
I've read through the ZMAP draft, and it's a really good starting point. It has some things in there like querying for addresses to see if they're being used. And in that regard, it's similar to what you would see with the link local stateless address auto configuration stuff. So there's basically have queries. This is address in use, and then you have address in use messages, basically saying, no, don't use that. I'm already using it. But there's a few other things that, of course, it would need. Addresses and ports. Right now, those are listed as TBD in the document. It wasn't quite clear whether it allowed for multiple MAASs. That stands for Multicast Address Assignment Server, I think. Whether it would allow for multiple on a host. I kind of got the impression that it only had a single one, and I didn't see a reason why you couldn't have multiple, but the environment that we're operating in, we want to allow for different applications running on the same host to also coordinate with each other and the rest of the network. You might find that on something like a PC installation where they might have a charting application and a radar application manufactured or designed by 2 different manufacturers and installed on the same terminal. And those pieces of software need to communicate with each other without relying on some sort of underlying assumption about what software is on the platform. The big one, of course, is required offending addresses with the same destination MAC address. Right now, it's tailored just to the IP address, both IPv4 and IPv6, and then allocate group IDs for zero-conf dynamic addresses. So if you look back a couple of slides ago, we talked about assigned addresses, both group IDs and actual addresses, and then there was a range for dynamic. I would propose that we carve out a range of that dynamic address specifically for zero-conf stuff. And that would be to avoid conflicts with a madcap server if they happen to be installed on the same network.
Yeah, just a question here. So you more or less only need discovery, it sounds like, at layer 2 or within one, the local link or subnet. Or do you think it's worth looking into potentially, having some mechanism that works multiple links or within a site, or?
Not sure I understand. Are you saying as far as discovering which addresses that you're interested in?
I guess, at least from what you said so far, it sounds to me like you only need uniqueness within one broadcast domain or within one link,
Right, yeah. Now, it doesn't mean that we wouldn't be interested in supporting other scopes.
Yeah. No, and I'm just thinking in some ways, it can be, there can be some solutions that are, available if you constrain it to a subnet or a link. On the other hand, it could be useful to solve a more general problem. So, Dino?
Hi, this is Dino. Again, great job on the presentation. So there is really a simple solution to do group allocation. You could just do hashing on the sources and receivers. I'll explain it in detail in a minute, but I have a couple questions about your deployment just to make sure it's clear. All the devices, the sources and the receivers are all on the ship, and that's a single scope of multicast that's going to run through a switch. There's no routers involved. Is that true or false?
That's true for our current conception. Now, when you start to get into larger container ships, it probably does make sense to start to put different subnets in there.
Okay, so the solution doesn't matter if it's multi-router hop or just single. And since you answered Stig's question about using multicast DNS, it makes the solution even simpler. Since you're using multicast DNS, you're looking up a DNS name. So you're actually naming each of the group communication that you want to do. So all you have to do on the sources and the receiver is run a SHA-256 hash on that name. That will create a unique address that both the sources and the receivers will sync to. You MLD on the receiver side to that address, and then you send from the source on the exact same address. You can ahead of time look at those names, and if they hash to the same low order 32 bits, which will collide at Ethernet, you pick a different name. So that part's static, but the sources and receivers can be dynamic. And if they hash, they'll hash to the same addresses. And the problem's solved. No third party, it's completely decentralized. Doing the hashing to figure out what the group address is trivial. I could write you a 10-line Python program in a second to do that. And the problem of group allocation is solved. Comments, reactions?
Yeah, so that's a really interesting idea. I think the thing about that, maybe I didn't mention before, is we also want to be as standard compliant as possible, so that oftentimes people aren't designing IP cameras, for example, specifically for the marine environment that will run this protocol. So we want to be able to take an off-the-shelf solution and put it on the boat, and we want those.
You run the group, the hash goes into the FF01 local scope, so nobody else can touch what you want. And if you want to play with the high order bits to make it unique from other applications, you can do that as well. But what we want the hash to do is, it's going to be a 256-bit hash, but you're going to truncate it to the low order 32 bits or anywhere in the middle. But the whole point is you don't want your multiple groups to have address collision. But that's easily avoided up ahead of time by picking the right sort of names. No random number generators, both the receivers and the source hash exactly on the same value because you want them to get the same group address. Make sense?
Well, yeah, it does make sense. I guess the question though is, if we were to say that's how the Onenet protocol should do it, how do we know that when we go to integrate other types of devices on there, because a lot of networks, marine networks, are not necessarily going to be marine only devices. We're going to have other, TVs and cameras and satellite systems and stuff like that. How do we know that we're not going to get collisions from those other devices?
The high order portion of the IPv6 address, you can put the prefix in there. And the prefix could be unique to these sets of applications. That's all. And those other ones won't do that, right? They'll use whatever their spec is.
But when you go to then transmit that on the Ethernet network, you still just have those 32 bits.
Yeah, right. Oh, so you're worried about MAC address collision. Yeah, that's a concern. You'll have to make sure that it doesn't happen. I mean, if you want to check the switch to see what groups are joined to see if there's collision, then you have to do collision avoidance or avoidance. I want to do collision. Well, you have to, sorry, I said the wrong word. You're doing collision detection. I want you to do collision avoidance ahead of time so you don't have to deal with the collision at all.
Right, yeah. Well, and that makes sense if everybody's doing that same collision avoidance algorithm. I think there's still potential for race conditions based off of who understands the state of the network at any given time, as far as calculating the names and determine, oh, somebody else has that particular one, I'm going to go on to the next one.
They have to all follow that same algorithm, right? Yeah.
Right, yeah.
And if there's two different sets of applications with a different set of rules, that's when the problem comes in. Yeah.
Yeah.
But we could talk about what you anticipate or think the future applications will be that may cause the collisions and address it. But at least for the ship, the picture you showed on this slide, there's a simple solution.
It's simple until you start.
We could talk more offline if you want to.
Yeah, sure. Okay.
Yeah, pretty cool idea. Just one thing, you're saying you might potentially have multiple applications on the same host, right? So you have an issue with that they have the same source address, so you need to put something more into the hash just to make them unique. Or
I think it's irrelevant of the source address because it's the group address that has to be unique, and that's what the IGP snooping.
Yeah.
This is an ASM application. That's why I think.
Yeah, we're not getting this. So
That's why I said we're just clouding the discussion by calling it SSM or ASM because it's right now it's on just a layer 2 switch. So we're joining groups and sources are sending to those groups. End of story, right? I mean, SSM and ASM is a concept for multi-hop router, multicast routers, right?
Yeah, I would, I guess, one bit of advice, I guess, that probably each of us who've been around long enough to know is, some of the old proposals you mentioned, ADCAP, and there was MASC, and we moved away from this many years ago, and there were good reasons, a lot of complexity, not worth the, and we ended up coming up with much better static derivable mechanisms. I think what Dino's suggesting is kind of another clever way of doing that. We've come up with Unicast, Multicast, prefix mapping. We've come up with GLOP. Each of these were addressing mechanisms that were derivable, simple, and didn't require, complex protocols. We got away from that for a reason. So I would caution against any trying to reinvent a wheel that we abandoned many years ago, because I think if you continue down the kind of derivable static path, you make, like Dino's idea, you may end up with, you'll probably be much happier in the end than having some server in service with a weird protocol that is just going to break. And
this is Dino again, real quick. In some deployments I've been involved with, if you have one source sending to multiple receivers, i.e. one group, we would make the group address be equal to the lower order bits of the source address, since it was always one source. And it was nice because if you wanted to look at content, you would know the source address by just looking at the group address. So that's another way, but that's a one-to-many only solution.
Yeah, I guess I can also mention that, yeah, like Torres was saying, often today, people just do the very basic thing where you register an address with IAN and just say like each device has its own just fixed address that you have registered. But the problem is, of course, if you have multiple devices, they can't just all use the same address necessarily. And you have the discovery part, I think, with the bandwidth and things like that. So I think just a static allocation would be difficult in this case.
Yeah, I was going to say another deployment is just put them in DNS and have the source under the same name that the receivers look up, and the applications just do a DNS lookup that maps to a group address. So that's just adding to what Stig said.
Right. Yeah, also I remember maybe 10 years ago or something, we started looking at some new discovering mechanism to avoid this static allocation, but it didn't really go anywhere. And yeah, the simpler you can make it, the better, But at the same time, it needs to work. So yeah.
Now, if you want to look into the future and you do multi-hop routing and you use overlays, you can now have independent paths because these addresses are relatively random. The hashing gives you the randomness that you want. So you can do a lot of good load splitting stuff because of this randomness that's already built into your group addresses using the first suggestion I said with hashing. So
I mean, as I'm thinking about this, I mean, again, I think the hashing is a really good idea. I haven't thought about that before, but I'm wondering is, as you start to, you have to detect collisions. And when you start detecting collisions, is the resulting protocol either just as or more complex than a protocol that just dynamically allocates everything?
good question. Well, what you do is you want to do collision avoidance. So and you can't do that on all the hosts if they don't want to join all the groups, because then they have to know the whole scenario. You don't want to have a protocol to do it. The fact is, if you find a good hash will produce pretty good randomness across 32 bits, so you may not have to worry about this problem. Now, I just don't want to say that because making that statement means it's going to happen, right? Murphy's Law, right? So that's why I said ahead of time. So what you're doing is statically you're picking these names. So these DNS names is a.abc.com, b.abc.com. And then you run it through this Python program that actually does the hash, because the source and receivers will do that dynamically when they want to join this content. The applications will decide which of these names they want to join or whatever. And so at that time, you will know ahead of time that since these things, in fact, let's put the names in DNS if you want, or MDNS. You don't even have to change that deployment. And then you know, because you've looked at all the current groups that are active in your network that are about to be active, and you know that the lower 32 bits are unique. So what you do is when you put these names in your own database, run the program across all the names, and it'll tell you if there's no collisions. And if there's no collisions, then you're good to go on your network. Now, when you want to add a new name, you run it n+1 across all of them. There's still no collisions. If you run n+2 and now there's a collision, then that name you just added is not unique enough. So just change the name, call it, A.1 or A.3 or whatever. If you change the lower order bits, there's a good chance that you get enough randomness in the 32 bits, and you're good to go. It's really that simple. Like I said, I'll write you the Python program. It's a no-brainer.
Well, yeah. So
I mean, you have developers.
right.
Yeah.
So let's say we do that. Then it comes down again to when you integrate another piece of equipment that doesn't do that.
Right.
There's a difference between an internet standard and a standard that is essentially just for boats. Right?
Yeah, you're absolutely right. And the chances are even those new set of applications that are not going to follow this algorithm will likely not collide. Not guaranteed, but likely not collide, because there's enough randomness in the 32 bits, right? And the thing is if we use all the first format you showed with 112 bits, it's a no-brainer. In your lifetime, you'll never duplicate. But since those 112 bits are going to map into only 32 bits of the MAC address, that's where you run into the problem.
Well, but when you do have that collision with that other piece of equipment, it would be very rare. And when that does happen, we can't expect our users
Well,
to figure that out.
Yeah, good point. If it does happen and it's rare, then you're no worse off than you are today. So do you want to play the odds? Just putting
Well,
that forth to you.
Yeah, no, I don't think we do, because our customers will just.
You'll
it just
lose the
doesn't
link,
work.
the 100 megabit link will.
Right.
It'll
It's
be
like, yeah, my
saturated.
sensor doesn't work. Well, what's
Right.
going on? And we're like, well, you're the only ones that this is happening to. Why is
Right.
that?
Well, yeah, I mean, you have to decide what the future is going to be with these applications and how they're going to do group addressing. And since it's going to run on your network, you need to be involved in making sure that there's no conflicts, right? So.
Right. But yeah, I mean, I guess we want to set ourselves up for success there, which.
I mean, there's no reason why you can't statically configure the addresses on the newer applications or use MadCap or any other mechanisms too. They can exist, right? Otherwise, you change that layer 2 box to a layer 3 box. And even though it's one hop, you'll get less problems with collisions, right? Because now the groups are differentiated by the entire IPv6 group address and not the lower 32 bits of a MAC address. So that'll help you. Just upgrade the layer 2 switch to make it a layer 3 router where the sources and receivers are directly connected, right? Yeah.
I mean,
yeah, you could do that.
I don't know. I mean, as far as third-party equipment and statically configuring those and all that, I guess I don't have a high degree of confidence that there would be an easy way for our customers to do that or even know to do that. I mean, certainly we could work on ways of detecting that and helping them resolve the situation.
The customers, they're the ones running the sources and receivers, or they're running the whole network, or
right, yeah. So
okay.
And then they go integrate, another piece of equipment that doesn't participate in this address allocation scheme, whatever it is, even this.
No, I'm saying if you're really worried about that and you want to solve the 1% case, it's less than 1% collision case, then make it a layer 3 router. And now you have the whole IPv6 group address, which is 128 bits. I think the rule is that the likelihood of duplicating an IPv6 address happens in like 120 years if you try to reallocate the address every second. So this is never going to happen in our lifetime or your children's lifetime or whatever. So because you have 128 bits to work with versus the 32. Because now the 32 bits just have to be unique on the Ethernet that's from the router. You know what I mean? So that you won't have the same collision problems. The router will be smart about it, right?
Right, but then, I mean, I think the problems introduced by putting a router in the network are maybe even
more. Okay, well, that's your call on that.
Yeah.
I see, Brian, I see you're online here. Did you have any comments on this, or sorry for putting you on the spot? I know you had some thoughts on this.
Hey, Stig. Yeah, so I missed the first half of the presentation, so there's probably some context that I'm missing there, but it certainly does seem like there are existing ways to address this problem, but I'm going to have to reserve comment until I can go back and review the materials and actually look at the scenarios to figure out what's going on. But I think some of the approaches that Dino pointed out may be worth exploring, but otherwise I'll look at the materials and post to the mailing list.
Yeah, okay, great, thanks. Yeah, I would say my feeling to you, I guess, yeah, speaking as just a participant, is probably good to try to avoid like big RAN solutions with something like DHCP or MadCap or something with a server and so on. If you can make it easy without any single point of failure or any new protocol talking to a specific device or whatever, something distributed like Dino suggested sounds much better to me. Yeah.
And the reason we're looking for simpler solutions are all the points that Torlis and Lenny made, is that we have many years of experience with these complicated protocol solutions, and they haven't taken off because they're just too complicated and people don't want to do it. They don't want to deploy and manage a MadCap or DH service just for this. So if we can find a distributed way of doing it, or static, it usually goes a long, long way. Because it's not, if it works or doesn't work, they all work, but they all have a cost associated with it. And so we want the cost to be trivial and for you to have the agility to maybe change the group allocation mechanism in the future without having to talk to vendors and stuff like that.
I always feel, somewhat useless of trying to give low-level detailed recommendations without having a good understanding of the deployment workflow, right? So, I mean, how is the stuff deployed? How, whoever, wants to see something, is this managed, right? Once I see that top-down use case details better, and maybe that's the thing that you may want to write down just as an informational document if you kind of want to support information. Then I think it's much easier to help with the design decisions what to do, because as I said, right, most likely one ends up and comes up with cool ideas, and then there is a stupid workaround, and whoever buys the stuff or makes the investment decision thinks that's good enough, and all the investment for the better stuff is wasted. Or we figure out the key points why something like this. I think auto negotiation is what I heard a little bit from Dino or so, is really key things that help. Yeah. Well, okay. Yeah, but I mean, all I'm saying is, right, I mean, we need to link whatever the suggestions are to why they're justified and necessary from, the operation perspective, what the use case is trying to achieve.
Yeah, I think from more like IETF process point of view, it would be great if you can write a draft and basically write down your requirements. And I mean, really happy to discuss solutions, but it's great to just have the requirements written down.
Okay, so just to be clear, next step is to write a set of requirements without any sort of proposed solution, just the requirements.
Yeah, I would say maybe initially at least just do the requirements, but if you want to, that document could later turn into a solution kind of thing. But just for discussion, it's good to just have those requirements kind of written down.
I think really just let's have an informal discussion about that. We understand the use case, the workflow better, and then I think it's easier to figure out if the answer from Stick, like, I think we have a clear list of requirements that we could help you write, if that's true or not, right? At this point in time, I'm not quite confident that I'm arrived at that stage, that there is a clear list of requirements that I could help to support without, first understanding the description of the workflow better.
Yeah, no, I think that's a good point too. And I made an assumption about that there would be an understanding about how these things would connect, and I didn't realize I made that assumption. So thanks for helping me realize that.
You do know how automatically working application solutions are now built on the network, right? You have all type of crappy equipment with thousands of nerd knobs, whether it's these addresses or whatever else. It's the application device, the switches and the routers, and you add a magical SDN controller and somebody goes and hacks some stupid stuff, and that's being resold, right? So that's the standard design process, right? And whoever basically is trying to write that SDN controller software has to collect all that information, right, to figure out how to make it run, and then nobody understands what's going on, right? So I mean, obviously that's the thing that is lovely if we can avoid it, right?
Go ahead.
Well, I was going to say, so I'll of course include this in the requirements, but just to kind of lay this out there, the expectation from our users is that they're just able to connect these things together and they work. They don't have to do any sort of network engineering stuff.
But then, we saw different sensors, right? So now the question is, okay, how does it even work? Does every receiver sees every sensor, and how is that receiver figuring out which sensor is providing what information? So there are multiple temperature sensors. You probably, need to know where on the ship they are, so that on the receiver you can display, okay, this is the temperature here, that's the temperature there. I mean, that type of use case stuff is really important to figure out how to do the auto configuration of that, right?
Well, and largely that's covered by the Onenet standard itself,
which we have no idea about, I guess. I hope. I mean,
sure. I mean, I guess I was trying to walk the fine line between providing too much information and not enough. We can talk about that however much you want. One thing that might be useful to understand is that NMEA as an organization helps companies resolve situations where there's problems, where they're implementing the standard differently. But aside from that, there's also a certification process that every device goes through that tests things like source address collisions and how they handle that.
But I'm really trying to understand it from the use case side, right? As I said, I mean, we're sitting there and trying to understand it. And so let's say we have a receiver device that I guess, displays some multiple different instances of the same type of sensors, like temperatures on different places of the ship. Is that what could happen?
That's one of the many things, yeah.
Okay, so let's run with one simple example so I understand the use case. So how would that display device know where and how to display the different temperature information? Is there well-defined, let's say, set of locations where you could install these things?
Yes, so there's a whole application protocol that's laid out there. Are you familiar with J1939 at all?
Yeah, of course.
I mean, so that's an automotive protocol.
Right.
The marine version is NMA 2000.
Yeah.
But all that is very well defined as far as here's the temperature sensor, it's air temperature.
So let's take it offline, but that's where I'm trying to ramp up to the level that I understand what you're trying to achieve, and then I think only can I give recommendations, right? Which is why these requirements where you're trying to derive your understanding from the application to what the network should do is something I cannot comment on because.
Yeah, I mean, I guess I wanted to distill it for what everybody was.
All right.
Focus.
So yeah, so that was amazing. Very good information, good presentation. There's a lot to digest there. We can help you create a draft if you want to go that route. If you do want to go a new protocol route, we can help you with that as well. It sounds like the recommendation is to not do that. If we do go the new protocol route, this would be the right place to do it. Otherwise, creating an informational draft, that probably would be best. We have a multicast operational group called MBOND that Greg and Lenny lead, and that kind of draft may be better in there, but we can talk about that offline. I would recommend grabbing Dino after this and talking some more.
Yeah, maybe I want to clarify too, when I say write a draft, I'm not saying it necessarily it will be an RFC or anything, just so we have something written down. I mean, you can send an email, of course, but I think it's good to just write a very short draft, just explain, your requirements. It can be a very simple thing. Just so we have a common reference and for discussion.
Okay, sounds good. I want to thank everybody for their time.
Thanks so much.
Yeah, it's great when you have time for good discussions like this, but now we need to move on. Yeah.
And to answer your question, Brian, we will share your slides, so go ahead.
All right, thanks, Mike. Hey, everybody. Sorry I can't be there in person, but if you go hang out with the DNS folks, they'll make all sorts of snide comments about how my work schedule kind of interferes with my IETF schedule. Just want to do a quick update on moving RFCs 3376 and 3810 to full standard. Yes, I'm presenting this, but there's also a bunch of people in the background helping me out. Anuj, Femi, Tim, Torlis, Stig. So this is really just me trying to reflect, what we've been able to do. So next slide, please. So I published a 03 version of the 2 BIS documents a couple weeks ago. As best I can tell, it captures all of the errata and identified issues that has been raised both in the design team and on the mailing list for making sure that the documents are ready to go to full standard, except for one thing. Next slide, please. So I posted the mailing list a little while ago about this one. So RFC 4604 describes how to use IGMP v3 and MLD v2 for SSM. And it does a formal update of both 3376 and 3810. There's, I want to say, like 6 or 7 modifications that 4604 makes to those 2 standards for the operation of the group management protocols, and it is a proposed standard in and of itself. And so the open question really is how do we want to handle this? Go to the next slide, please, Mike. So I see 2 options. And the one I think I recommended on the mailing list was we actually incorporate the protocol changes from 4604 into the 2 BIS documents. I think what that requires is for us to agree that the fact that 4604 has been around for 15 years as a proposed standard is actually ready for advancement to full standard as well. I don't think I'm going to get an argument out of anybody from the multicast operations side, because SSM has been used in a variety of places and in a variety of ways, and that document seems to be pretty solid. So if we do that incorporation of protocol changes, then both 3376 and 3810 biz would mark 4604 as obsolete. The other way of going about this would be to create a 4604 biz and advance that in parallel with the other two. But I don't see that keeping that separation makes a whole lot of sense. May actually be confusing new readers. And then we'd basically end up having 4604 biz update 3376 and 38 biz. Next slide. So my suggestion to the working group is that we actually do that incorporation, pull everything into the 2biz documents, and 4604 goes away. You know, Alvaro made the comment on the mailing list that we would want to make sure that we actually provided that justification in the Shepherd write-up, and maybe possibly in those two documents, but most likely in the Shepherd write-up. So that's all I had. Questions, comments? I see AC in the queue.
Hey, Brian, AC Linda, Cisco Systems. I agree with that. It doesn't make sense to keep them separate, and they should be advanced together. To do it to full standard, don't you have to produce some other document on the implementation and do this survey and all this extra work, or don't you have to do that? No.
All of that's already been done. That was work that was done prior to the start of the 2biz documents. So we have implementation survey reports that back up this material.
Okay. Thanks.
Sure.
Stig here. So yeah, you feel the survey that was done covers all you need to ask for 4604?
So I think we'd probably have to go back and do some additional work for 4604. And I did not include that in the slides as a work item, but I think from the perspective of what I have seen in an operational and implementation perspective, that survey should be pretty straightforward and wouldn't be a big time sink.
Okay. Yeah, this personally, as a working group participant, I think it would be a good idea to include this because I don't know. I've seen implementations that implemented just IGMP-v3 or MLD-v2 and then somehow overlooked some of those SSM requirements. And I think the only reason 4604 is a separate document is that it was kind of done after those base protocols, right? But
Yep,
SSM is really important to us. So yeah.
Yeah, and I will fully admit that. You'll find that I'm listed as a co-author of 4604 along with Hugh Holbrook and Brad Kane. So, part of this was we didn't want to immediately turn around and open up 3376 and 3810 again, given that people were trying to implement those versions while we were also working on the SSM side. So,
right. Yeah, by the way, I'm sure you checked the 4604 errata, and I just checked myself too, and there's only one small comment I see.
Yep.
Let's see, Dino is in line.
Hey, this is Dino. Brian, I don't want to throw a monkey wrench in this, and maybe this is a separate effort, what I'm about to suggest is, do you think MLD could be a dual stack reporter? In other words, IPv4 group addresses can be embedded in IPv6 addresses and just run one protocol to join V4 and V6 groups. So I don't know if it has anything to do with advancing these documents, but maybe it's some new effort. And is there any value at this point? I'm looking at the chairs to see a reaction, and they're moving their heads up and down, and I can't see their expressions because there's masks over there.
So Dino, you're going to get a snarky answer from me. Put your toolbox away.
Okay.
Yes, I know that. Yes, we could look at. Yeah, we could look at something like that, but I definitely think that that would be a next
A
kind
new
of
effort.
version thing. So. So I guess for Mike and Stig, if you want to do a consensus call on the mailing list, or if you want to declare a consensus, if Alvaro is sitting there and can back you up, that we'll start looking at the 60, doing a 4604 incorporation, and then I'll see if I can talk to folks who worked on the implementation reports to also do one for 4604.
Yeah, we're going to do a quick poll right now, Brian, just because when we issued an adoption call on one of your last drafts, we got 0 response. So I think our best response is right now.
Yeah, so this
Works
is
for me.
pretty informal, but just
Yeah.
to get some idea of what people think. So just doing a quick poll here. So basically just asking, do you think 4604 should be incorporated? I guess it's up there now. Just to get some quick idea what people feel like. Yeah, it's looking pretty clear here. But yeah, I think the biggest problem is just like just dealing with if you have sufficient implementation status, whatever, and of course the analysis, to see if there's some parts of the document, that have not been implemented or isn't mature or whatever. I don't know how you feel about that. Is basically all of 4604, you think, something that everyone implements, or?
So I think there's really 2 ways of looking at it. When we wrote 4604, we specifically marked what pieces of the document were modifying 3376 and 3810. So we could focus on just those aspects and get those incorporated into the biz documents. Otherwise, it'd be a little bit more work just to see how, what does the survey look like for 4604, and I'd have to think about that a little bit, but
Yeah, but yeah, at least we got 15 people responding, all saying it should be incorporated, so that gives you some idea.
Yep.
We
I
can
appreciate the
check on
input.
the mailing list too, of course.
Yep.
Yeah, we definitely should check on the mailing list. Great if you can send an email asking, or you already did, I guess.
Yeah, I can poke the mailing list again and just explicitly ask for a response on that approach.
Yeah. Okay. Yeah. Great.
Okay, great. So we got 15 in favor of that, so, and none against. So I think we'll probably do that. And then our
illustrious AD wants to say something.
Yeah.
Hey, Arunaratana, Andy. Yeah, so just to point out for the process point of view, just so we don't forget for the future. I hope this is done soon, right? And maybe I'm still the AD and I can process this stuff. When we go to internet standard, one of the requirements is that there haven't been significant changes to whatever the document was before. Now, in this case, because we're incorporating this other thing, it may look like there are significant changes, right? So we're going to want to, and Brian already said it there, but I just want to say it again. We're going to want to justify why it looks like there are significant changes, when in reality there aren't, right? Because we're moving 46, whatever, into internet standard as well as part of the other 2 documents. So I don't know if we already have a shepherd for these documents, but if we don't, we should probably find a shepherd now and start documenting all this stuff, so that by the time that this gets to the IESG, we don't face questions of why the heck are you changing all this stuff, because we're not. We're just incorporating the changes that were already done 15 years ago. So just to keep in mind for the process and the minutes and all that stuff. Thanks.
Yeah, that's certainly important, and definitely good to get a shepherd. I don't know if it matters, but one thing I can imagine is if someone implemented just the base IGMPv3 RFC and not the SSM part, not 4604, then the problem would be that you're not compliant anymore, or wouldn't be compliant with the full spec. But on the other hand, though, you really want everyone to implement the SSM part. So they can still claim compliance with the old RFC, of course.
Okay.
Yeah, let's move on.
This is the very last presentation. I don't think the authors are here. They're in India, and we told them to take it to the list and get some feedback, which they haven't done yet. But they did send us some slides. Maybe we can go through them real quick. Hopefully you read this as well, Stig. My take on this is they are proposing to standardize static multicast routes that are extended to include forwarding locations. So like a static IPM route, for instance, in your vernacular. And instead of just pointing back towards the source for a particular source and group, you're also extending that to show where that traffic should flow to. And also to be able to have a redistribute option that can be interoperable with multicast protocols. So go ahead, Torres.
Yeah, I haven't read it, but from the description, it sounded like if that would be something like a Yang model for programming these things. I mean, there has been CLI to do these things on the various vendor equipment, not a single command, but multiple commands through which you can combine to achieve these things. And you know, lots of nice hacky customer deployments relying on that stuff. So maybe it's more an M-Bone-D thingy than if it's a Yang model. Also, I have no idea on that stuff. But
I don't think they do. You guys don't work on Yang models, do you?
Because it's more, you know, mostly given how this came from hacky tools routers have. I was thinking of this that way. But
go ahead. Go ahead.
Lenny Giuliano, Juniper, and yeah, we do. We have a Yang draft. I guess you haven't reviewed it.
Nope. I avoid Yang.
I would, in the first place, look if they come up with good current use case that makes somebody excited about this, right? To get it standardized.
Well, the question I have also is standardizing static multicast routes. Is that a thing that we would want to do?
No, it's standardizing the configuration of setting that up exactly, right? As I said, there's a lot of CLI to do this in the different routers forever. So.
Right. Yeah, I also think, you know, this is something that everyone implements pretty much, but they might do it in slightly different ways. And I don't know whether we want to standardize one specific way that maybe, you know, wouldn't match what various implementations do. And it's very local to the device. So do we need to standardize the static route itself? But like a Yang model, for instance, that's something that we would need to standardize. Maybe. I mean, I certainly see value in a Yang model.
So I know implementations call a multicast static route really configuring the input and replication list. Maybe a better name, if you want to standardize it, is to call static distribution trees, because it's even though you configure the route in one router, you have to configure it consistently all the way downstream as well. And then the question has to ask if the path is the input interface that you configure on the static route the current RPF based on what Unicast is saying, and if it changes, should it change or should it not because it's static?
Yeah, so at least this draft discusses both options. You can do it static or the RPF can be dynamic.
Yeah, I mean, technically speaking, I think static is a protocol, and so this is, a protocol working group. The question I would have is there a Unicast static route RFC? Whatever we did for Unicast, I think we should do for Multicast. If we didn't need it for Unicast, we probably don't need it for Multicast, and vice versa. But if there is an RFC somewhere on static routing, probably not a very interesting RFC, and probably hopefully short, we should do it for, it seems okay to do it for Multicast.
Yeah, I mean, there should be probably, I hope, a Yang model for static routing entries, right? So that's the RPF stuff I think that Dino was referring to. Then there's this IP IGMP static join and static group, and I think those were pretty consistent, Juniper and Cisco, and since then I've kind of lost track of whoever else did additional stuff. But yeah, I mean, this stuff has been deployed, and people, before even there was the word SDN controller, when they had routing problems for which our dynamic routing protocols couldn't help, some of these embedded type of networks specifically were using all this stuff. But again, question is there sufficient, future going use case interest? And I think MBOND would at least be a good place to kind of vet that, and then we can take the next steps.
Yeah, given that static is used a ton as far as I know, it could be maybe it could be good to document in MBOND a little bit like operational practices or issues with static config on it.
So I'm glad Lenny led the opinion. So, and then I'll just echo it more stronger. I think this should definitely not be specified and not standardized, because then when you get into redistribution mechanisms, what if PIM's running over this router that has static routes? What do? Does one override the other? There's a lot of machinery that would have to be spec'd out to get this right. And if you provide a recommendation and it's wrong, it's going to screw up networks. So let's just avoid this monster altogether.
AC in the line?
Yes, AC Lindum Cisco Systems. I wanted to just say the rumors of a static routing Yang model are not exaggerated. I'm an offer. I can't remember the number though. And for the Yang model for OSPF, we got together all the I'd like to say all the major vendors, and a lot of things that we had left unspecified in the protocol, we did put into the Yang model, which would, and we allowed in many cases, we used features and allowed multiple ways of doing things. So we could get, it was people from, Juniper, Cisco, Huawei, and Nokia, I think, were the people that worked on it. And so it did end up to be a lot. But once you get to the Yang model, we did get into this. We did not specify redistribution. And that's still something that people ask about, though, for a Yang model. That's all I had to say.
Thank you. Anything else? So as far as this draft goes, we'll inform the authors of what comments were made, and again, to suggest that they send this to the list and ask for comments, and maybe include MBOND. And I'm excited because I have just a little battery left, and I think we're at the end.
All right.
We good?
Yeah. All right. So, yeah, do you want to?
We're done. Thank you.
Yeah, I'm really happy with my laptop. The battery lasts forever. I feel like.
Yeah, I
I've
do.
done 20%. I mean, about 80% left.
Oh wow, that's really improved. What do you got?
No, it's a
ThinkPad.
Lenovo.
Okay.
Yeah, at first I almost thought you had the same computer as me. The design looks a little similar.
Yeah, it does. Yeah.
Yeah, good to see you.
Yeah, I know. No kidding. Finally, it's been years. Like literally.
Yeah.
Yeah, it's actually really, it's really nice to be back.
Yeah.
I'm looking forward to.
Yeah.
I'm looking forward to.
I meant